Hello viewers, welcome to another episode on LFX live class. Today we'll be doing mathematics and the topic today will be indices and standard form. After today's class, nothing in indices and standard form will be so hard for you to understand again. Now what is indices? Indices simply means numbers or letters that are in form of powers, that are having powers, just like 2 raised to power 2. If it can have power, this is in index form. You can either call it indices form, index form, or indical form. All this simply means the same thing. So now, after solving a question and you are asked to drop or leave your answer in indices form, it means it must be in this form. And you are asked to put your answer in index form, it will be in this form. You're asked to leave your answer in indical form, it will also be in this form. So indices simply means numbers or letters. It can also be a raised to power 5. It is also in index form. So once a number or a letter has power, that letter is in indices. That simply means indices. Now coming to standard form, they are similar. It's just that standard form always comes with times 10 raised to power anything. So the difference between both of them is that you have to have a number that will be times 10 raised to power any other anything it will be up. For example, 5 times 10 raised to power minus 2, and this is the standard form. Or 5 times 10 raised to power 5, 4 is still in standard form. So why they are working hand in hand is that this 10 raised to power is still having power and it's also in index form. So today we will be solving some similar questions that JAMB sets or even WAEC or even GCE or any exam you want to write. So now we'll be using some examples like, remember we're going from known to the unknown. So we'll start from the known. Example can be x times x times x times x. Now, since there is x here, x here, x here, and x here, you pick one x. You pick one x, you count. There's one x here, there's one x here, there's one x here, there's one x here. I'll be teaching you two ways to solve this thing. Any way you wish that is simpler, you can choose. You still arrive at the same answer. Now, since there is one here, you can say 1 plus another one here plus, because times is changing to plus, of another one here, then plus 1. Therefore, the answer becomes x raised to power 1 plus 1 plus 1 plus 1, x raised to power 4. So this is the answer of this. Or you can just, since there's x here, x here, x here, and x here, you can just pick one x. If you pick one x, you count the x's you can see 1, 2, 3, 4. Then you put 4 on top, x raised to power 4. So either this or this, both of them are correct. Now, another example we can have is 2a raised to power 2 times a raised to power 5 times a. 2a raised to power 2 times a raised to power 5 times a. In indices, like I said before previously, that times will change to plus, but division will change to what? Minus. So just have this in the back of your mind in case we enter the minus side, the division side. Now, since we have this thing as the question, we're bringing out the number we can see first. So the number is 2. Only one number we can see. There's no number here, there's no number here. So bring out 2. We can see A here, and A here. Times, pick one of the A. How many A is written here? It is 2. And then this is times will change to plus. How many A is written here? 5. Plus, how many A can we see here? 1. So I go again. This is 2. Bring out the numbers first. Times, there is A here, and A here. So you pick one A. So you start from the first A you pick. What is up here is 2. You put 2. times will change to plus. Next A here is what? 5. Times will change to what? Plus. Then A again here is what? 1. Do it this way gradually. So it's equal to 2 times A is 2A. Now 2 plus 5 is 7 plus 1 is this becomes the answer. Therefore, the answer to this question is 2 raised to power 2A raised to power 8. And this is not so hard. Another one we can have is 32 y raised to power 4 times 2 y raised to power 2 times y raised to power 3 over 16 y raised to power 2 times y. This is another question. 32y raised to power 4 times 2y raised to power 2 times y raised to power 3 is divided by 16y raised to power 2 times y, or y raised to power 1. So the first thing you do, like this way, I told you bring out the numbers first. There is 32 here and there is 2 here. So you bring it out. We have 32 times 2, then times, there's y here, there's y here, and there's y here. You pick one y. How many y can you see here? We have 4. Times will change to plus. How many y can you see here? 2. Times will also change to plus. How many y can you see here? 3. Divided by, the only number we can see here is 16. So you bring 16 times, there's y here, there's y here. You pick one y. How many y is here? 2 plus, because times is changing to plus then. How many y can you see here? 1. Which is equal to, you can times if you want, but to avoid using calculator, since 16 can divide 32 without remainder. So let 16 divide 16 to give you 1, and 16 divide 32 to give you what? 2. So what is left? We have 2 for this here, for this 2 times, there's another 2 times, then there's y. Now we can add 4 plus 2 is 6, 6 plus 3 is 9, divided by 1 is left here, and 1 times y is the same thing as y. 2 plus 1 is now raised to power 3. So the final answer can now be 2 times 2 is what? Is 4. 4 times y, 4y raised to power 9, divided by y raised to power 3. Remember, the rule states that nobody should stay up and nobody should stay down. So now we'll bring it up. Therefore, final answer will now be 4y raised to power 9. There is 3 up. The 3 go, if there's 3 down, if the 3 goes up, it changes to minus 3. Now the final answer becomes 4y. 9 minus 3 is now 6. So the answer to this question is 4y raised to power 6. Now, let's touch standard form a little bit. Remember, like I said before, that standard form was half times 10 raised to power any number. Now, for example, we have 0.1. We have 0.001. We have 0.0001. We have 241.43. We have 672,341. And we can also have 1.667. So let's finish this question first. The first one is 0.1. I'll be teaching you 2 ways. two simple ways to solve this. The first way is, this is 0.1. Now, where can you find the point? The point is in between 0 and 1. So now, there are two things you should note. You are shifting from this point till you get to a particular number. Once you get to a number, you stop. Standard form says that once you get to one number, after the number, you should get your point. Now, the first way I'll teach you to solve this thing is using shifting of points. And this is the point here. You shift it, remember, till you get to a number. So we shift. We have gotten to a number, you stop. Once you get to a number, you are stopping. So this point is no longer here, it is now here. So to find the answer is now, first of all, write this number you got. 1. Remember, the point is no longer here, it's now here. Now, point, say nothing, times 10 raised to power. How many times did you shift? Only once. And now, shifting this way, shifting to this side is the right hand side, and shifting to this side is the left hand side. If you are shifting to your right hand side, your power will have minus. But if you are shifting to the left hand side, your power will not have minus. I'll say it again. If you are shifting from your point to the right hand side, your 10 will have raised to power minus. If you are shifting to the left hand side, it will not have minus. So now, remember, how many times did we shift till we get to a number? We shifted only once. So it's now times 10 raised to power minus 1. This becomes the answer. But the second way to solve it, the fastest way to solve it is, once you see the number and it's starting with 0, if you check this question A now, it has 0 points. It's starting with 0. So now if you should start with 0, first of all, numbers you can see, they just put 1 times 10 raised to power. We don't know what will be on top of here. Now, since it's starting with 0, you should have minus first. Once you put your minus first, since you can see 0 first, now ask yourself, how many zeros can I see there? Only 1. You now put 1 on top. So you can still give it the same answer. Is either this or this. So the second formula is checking the numbers of zeros you can see. And since it is starting with 0, you should have minus. Very good. Do the same thing, the other one. B says, okay, let's solve here now. B says 0.001. Now, using the first rule, we're shifting the point till we get to a number. You count. 1, we've not gotten to a number. 2, we've not gotten to a number. Now, 3, we've gotten to a number. So now you write the first number you saw, which is 1. Point is no longer here, it is now here. Point nothing times 10 raised to power. You shifted to the right hand side. So remember, you have minus. How many times did you shift? You shifted 1, 2, and 3. So minus 3. Or you use the other way, which is counting the zeros. So how many zeros can you see here? 1, 2, 3. So it will be 1 times 10 raised to power. If you're starting with 0, it will have minus. Then count the zeros. 1, 2, 3. Minus 3. So both of them are giving the same answer. Now the fourth one, which is C, is 0.0001. Same way. So if you shift 1, 2, 3, and 4, it becomes 1.0 times 10 raised to power minus 4. Or count the zeros, 1, 2, 3, 4. So it will still give you minus 4. Alright, going to D. D is looking somehow different. We're going to solve it. So we have 241.43. 241.43. What is the rule again? That after a number, you see the point. After the first number, you should see the point. Now, if you check where this point is, it's in between 1 and 4. Am I to shift to the right hand side, or I should shift to the left hand side till I get to this number? So if you're looking at it, I'll have to shift to the left hand side. So I'll shift 1 and 2. So the point is no longer here, it is now here. So to get the final answer, it becomes, bring it down, 2. The point is not here, it is now here. 0.41. Now, if you're writing the answer, you're going to have these two things too. So 4143 times 10 raised to power. How many times did you shift? 1 and 2. And remember, if you are shifting to the left hand side, it's not having minus, so it becomes times 10 raised to power 2. He says 6, 7, 2, 3, 4, 1. Someone will ask me, where can I see the point here? There's no point in between 6 and 7. There's no point in between 7 and 2. There's no point in between 3 and 4. Nor there is points in between 4 and 1. Now you remember, after making a sentence, your full stop should be at the end. Now therefore, the point is not in between any of these numbers. Rather, it is at the end. The rule states that we're going to shift the point to get to the first number. So now we'll shift 1, 2, 3, 4, and 5. So the point is no longer at the back, that is at the front. So to solve it, it now is 6. Bring down 6. Point that is not here will now be here. 0.723, 4, and 1 times 10 raised to power. We shifted to the left hand side, so it will not have minus. So you shift. Count again. 1, 2, 3, 4, and 5. So 10 raised to power 5. Now for F we have 1.667. Looking at this F, after the first number, the point is already there. So since after the first number, the point is already there, we're not shifting anything again. So you bring it down, 1.667. Check the question and check your answer. There's no difference. Where there is 1, there is 1. Where there is point, there is point. So since you didn't shift anything, the answer now is times 10 raised to power nothing, because you did not shift. And checking, confirming. Remember that anything raised to power 0 is equal to 1. So now if you times 1.667 times 1, to still give you the answer, which is 1.667. So the answer to this thing in standard form is now 1.667 times 10 raised to power 0. Today, at this juncture, we will be ending the class. But if there is any question, you can drop it on the comment section. Don't forget to continue watching our videos. Next class, I'll be posting more questions. I'll be solving more questions related to JAMB. Don't forget to follow us. Thank you and bye for now.